Section 7.3, Scientific Notation. Essential question, how do you write a number in scientific notation? The definition of scientific notation is a shortened way to write a really big or small number. So let's say you have the number 10 trillion. Rather than writing out all those zeros, you can put it in scientific notation and it's much quicker and easier. Or if you have a really small number like 0.0000007, you can take a really small number and put it in scientific notation, which is much shorter and quicker. Alright, so the first two slides we're going to write numbers that are currently in standard form and into scientific notation. Just a normal number, like for example this one, 5,300, that's in standard form. All numbers start out in standard form. Then we're going to put them into scientific notation. So the first thing we have to ask ourselves is, where is the decimal right now on 5,300? Well, the decimal on any whole number is at the very end. So I'm going to put my decimal right there. Now our rule for scientific notation is we always want the number to be between 1 and 10. So I have to ask myself, where do I need to move this decimal so the number will be between 1 and 10? Well, if I move it once, I have 530. That's not between 1 and 10. If I move it twice, I have 53. That's not between 1 and 10. If I move it a third time, I have 5.3. Yes, that is between 1 and 10. So I'm going to stop and write 5.3. Then for scientific notation, it's always times, and we actually do use the X for times for scientific notation. 10, you always put a 10. That's just a part of scientific notation. It's always times 10. And then you count how many times you moved your decimal. Well, like I said before, we moved ours 1, 2, 3 times. Now sometimes we'll have positive exponents, sometimes we'll have negative. The way you know is I always say if it's a big number, so 1 or higher, then it's a big number, meaning a positive exponent. If the number is smaller than 1, then you have a negative exponent. So 5,300, my original number, is a big number, so my exponent is positive. Alright, 68,700,000. Just like 5,300, the decimal is always at the very end. Oh, one thing I forgot to mention about the problem above, you don't need these zeros. As soon as you get to constant zeros, you don't have to write them. So I don't have to write 5.300. You don't need the zeros there. Okay, so I'm going to move this decimal until I get to a number that's between 1 and 10. And notice I'm making these little loops in between each digit. If I stopped there, I'd have 687, not between 1 and 10. If I stopped there, I'd have 68.7, not between 1 and 10. If I stop here, I have 68 or 6.87, which yes, that's between 1 and 10. And then I'm going to count how many times I moved my decimal. 1, 2, 3, 4, 5, 6, 7. 68,700,000 is a really big number, so my exponent 7 has to be positive. All right, 20,100. Start at the end. Move my decimal. 201, nope. 20.1, nope. 2.01, yes, that's between 1 and 10. Again, I don't need to add all those zeros on at the end. Times 10. And I'm going to go back and count how many times I moved my decimal. 1, 2, 3, 4. 20,100 is a big number, so it's a positive 4. And the last one is just the number 7. Now you think, wait, why would I write the number 7 in scientific notation? It's a fairly small number. Yes, but we are still going to practice writing even that kind of number in scientific notation. Now the number 7 has the decimal at the end. Now, we also know 7 is between 1 and 10. So we can still write 7 or 7.0. If you want the decimal in there, either way is fine. Times 10. 7 is considered, even though it's not as big as the other ones, it's still considered a big number because it's higher than 1. And I didn't move the decimal at all, so I can put times 10 to the 0. Which anything to the 0 power is 1. 7 times 1 is 7. So that would still get us with what we started with. All right, now you'll notice we have numbers smaller than 1. We're going to deal with some small numbers. The last slide was all bigger numbers. These are small numbers. For the small numbers, we already have the decimal in place for us, but we still need our number to be 1 through 10. So rather than moving our decimal to the left to get it between 1 and 10, we're going to move it to the right. So if I move it once, I have 0.34, not between 1 and 10. If I move it twice, I have 3.4. Yes, that is between 1 and 10. So 3.4 times 10. I moved my decimal 2 times. And then 0.034 is a small number. It's smaller than 1. So my exponent has to be negative. Don't forget the negative exponent. All right, 0.00005. I will keep moving my decimal. 1, 2, 3, 4, 5 spots gets it between 1 and 10. So we could write 5 or 5.0, doesn't matter, times 10, and I said I moved my decimal 5 spots. 0.00005 is smaller than 1, so my exponent is negative. 0.00125. Move my decimal 1, 2, 3 times. I'll stop there because 1.25 is in between 1 and 10. I moved my decimal 1, 2, 3 times. 0.00125 is smaller than 1, so then it's considered a very small number, so a negative exponent. And 0.7. 0.7 is not between 1 and 10, so I have to move my decimal just 1 spot, so it becomes 7. I moved my decimal once, so my exponent is 1. 0.7 is smaller than 1. It's a small number, so my exponent is negative. So those 8 examples were going from standard form to scientific notation. Now we're going to go the opposite way. We're going to take our scientific notation number and put it in standard form. So my first one is 3.201 times 10 to the 5th. Now the first thing to look at on this is what the exponent is. That 5 is positive. Positive means it's going to be a big number. So that means I need to move this decimal. You have to think, okay, well, to the left would make it a smaller number. To the right would make it a bigger number. So I need to move my decimal to the right. So if I take 3.201 and I move my decimal 5 spots to the right, 1, 2, 3, 4, 5. Now in those loops with no number, we're going to add 0. So we'll put a 0 here and a 0 here. Now if you want, you can rewrite your number again so it looks a little nicer without the loops underneath. And we can add in our commas. Remember, every 3 numbers starting with the right, you add a comma. So my answer is 320,100. Since I had a positive exponent right here, 5, a big number, check at the end. Do you end up with a big number? Yes. 320,100 is a big number. All right, 6.32 times 10 to the 2nd. So again, I have an exponent of positive 2, so that means it's going to be a big number. So if I take my 6.32 and move it 2 spots, I'm I'm going to go to the right because it's positive. I need it to get bigger. If I go to the left, it'll get smaller. 1, 2. So my number is 632. And I can check, did I make a big number? Yes, I did. 632 is big. All right, 4 times 10 to the third power. Now there's no decimal in 4, but I can add it in just like on that first slide. We added it in at the very end of the number. So if I have 4, I'm going to move my decimal. Again, we have a positive, so it's going to be bigger. So moving my decimal to the right will make the number big. 1, 2, 3. And this is one where I have to add in zeros into my problem, into all the open spaces. So 0, 0, 0. So then we have 4,000 for our answer. Okay, last one on this slide, 9.03 times 10 to the 0. Now 10 to the 0 means that I'm moving my decimal 0 times. So my number is going to stay what it was in the first place. Because that 10 to the 0, I'm moving the decimal 0 times, or 10 to any number to the 0 power is 1. So it'll just stay 9.03. Alright, so now we have a page of negative exponents. So negative exponents means our number is going to be really small. So if I want 7.6 to become even smaller, I need to move my decimal, and I'm going to move it one spot. Instead of to the right, I'm going to move it to the left. Moving it to the right would make it bigger, it becomes 76. Moving it to the left becomes smaller, it's 0.76. 3.45 times 10 to the negative second. So my exponent is negative, so my number is going to be small. So I'm going to move my decimal 2 spots to the left to make it smaller. 1, 2. Fill that in with a 0, and my answer is 0.0345. 2 more. 8 times 10 to the negative 7. 7 is negative, so we're going to be looking for a small number. 8, my decimal is right here on the right. And you'll notice I left a lot of space between the problem and the 8, and that's because I know I have to move my decimal 7 spots to the left, so I wanted to leave myself space. 1, 2, 3, 4, 5, 6, 7. So put your decimal in and add in your zeros. 1, 2, 3, 4, 5, 6 zeros. So my answer is 0.1, 2, 3, 4, 5, 6, and 8. So very small numbers for our answers on this page. And the last one, 1.52 times 10 to the negative 5th. Exponent is negative, so I'm going to move my decimal to the left. I'm going to move it to the left 5 spots. 1, 2, 3, 4, 5. Add in my zeros. And I'm left with 0.00000152. So double check when you're all done. These 4 all ended up very small because they had negative exponents. The back of page, they all ended up very big because they had positive exponents. Summary. And the homework for this lesson is page 419, numbers 1 through 10, 20 through 33.